Hi everyone, this is our last lesson for the topic of surface area. And in this video we're going to look at the surface area of composite solids. So this is what we've learnt so far. We've looked at the area of plane shapes, surface area of prisms and pyramids, and then last lesson we looked at the surface area of circular solids including cylinder, cone and sphere. Now before we get on to composite solids, I want to look at some modifications to the basic shapes, like hemisphere. If we want to find the surface area of a hemisphere, we need to include the bottom circle as well. So not only do we need to do this outside surface, but we've also got to add in an extra circle. So here's the calculation. Let's see if it makes sense. 4 pi r squared is the surface area of the sphere, and we only want half of that. So that gives us this dome. Then we want to add in an extra circle, which is pi r squared. And putting that into the calculator, we get 84.8 meters squared. And this is an interesting one as well. It's a truncated cone, which just means it's a cone that's had the top removed. So if we want to calculate the area of the curved surface of this shape, then we need to work out how tall the cone was before the top was removed. So let's move this down a bit and we're going to construct the top of it. Now we need to find the height of it. So I'm going to call this little part up here h. And we're going to use similar triangles, which some of you might not have done before, but it's just a fairly simple exercise in ratio. What I'm going to do is h over 2 will equal h plus 5 over 10. And fairly easy equation to solve. 10h is equal to 2h plus 10. And solving that, I'll leave you to do this, we get h is equal to 0.8. So now that we have that measurement, we can work out the slant heights. And there are two that we need. We need the slant height of this top cone that's been removed, and also the slant height of the total cone. That's just Pythagoras' theorem. Let's start with S1. So this length here is 5.8. It's going to be 5.8 squared plus 10 squared, which is 133.64. Do the square root. And so the slant height of the total cone is 11.56. Now let's do the smaller one. It's 0.8 squared plus 2 squared, which is 4.64, and the square root gives us 2.15. All right, let's try and put this all together. To work out this curved surface here, we want to do the curved surface of the total cone, take away the curved surface of the little cone up the top. So it's going to be pi r s1, take away pi r s2. Substituting in, and we get 349.7 centimeters squared. Now this might have occurred to you. When we calculate the surface area of a shape, do we only do the outside or do we do the inside as well? Depends on the question. If we're calculating the surface area of a closed shape, then we only look at the outside surface, like those particular shapes there. But if the shape is open, then it depends on the question. It's possible we'll need to consider the inside surface as well. Usually they will tell you. So we did a question in the last video where we looked at rust proofing this cylinder, and we had to do the inside and the outside. So just read the question carefully. All right, let's move on to composite solids. So a composite solid, remember, just like a composite area, will be comprised of two or more solid shapes. So here's our first example. Calculate the surface area of this shape. The best way to attack a problem like this is to make a plan. Think about what you're going to have to do. All right. Firstly, we're going to find the surface area of that rectangular prism. Then we're going to find the surface area of the cylinder with the top only. And then finally, we're going to subtract a circle from the total. Let's have a think about why we've done all that. So rectangular prism, we want all 6 sides. That'll give us this bit here. Then we're going to do the curved surface and one circle of the cylinder. And then finally, we're going to subtract this circle from that top face. All right, surface area of the rectangular prism is pretty easy. I'm going to use the formula. So it's 2 lots of 10 times 5 plus 10 times 5 plus 5 times 5. That gives us 250 centimeters squared. The surface area of the cylinder with the top only is 2 pi rh, that's our curved surface, plus 1 circle. Our radius is 2.5. Substituting that all in, we get 82.47 centimeters squared. And then finally we're going to add those up and subtract the circle from out of this top face of the prism. Okay, so we get 250 plus 82.47, take away pi times 2.5 squared, which gives us 312.8 centimetres squared. Here's another one. A toadstool is made in the shape of a hemisphere on top of a cylinder. The cylinder has a radius of 3 centimetres and a height of 5 centimetres. The hemisphere has a radius of 6 centimetres. Find the total surface area. Alright, let's think about a plan. So firstly we're going to do the hemisphere, but we're not going to do the bottom circle. Then we're going to do the cylinder with only a bottom. And then finally we're going to do this donut shape in here, which is going to be the outer circle with radius 6 centimetres, take away the inner circle with radius 3 centimetres. That shape there, that donut shape, is actually called an annulus. So let's start with the hemisphere. So remember the formula is 4 pi r squared and we want half of it. And we're going to have to use the full radius, so 6 centimetres. So that's 226.2 centimetres squared. Now we'll look at the cylinder. Now we want the curved surface and one circle for the bottom. And this radius is going to be 3 centimetres. So here's the curved surface, 2 pi rh, and then there's the bottom circle. And so that is 122.5 centimetres squared. And then finally we want the donut shape. Now what we're going to do here is do the area of the outer circle, which has got a radius of 6 centimetres, and then subtract the area of the inner circle, which has got a radius of 3 centimetres. And that gives us 84.6 centimetres squared. And so our total surface area is 433.3 centimetres squared. The toadstool is to be covered in 24 karat gold leaf, which comes in papers measuring 80 millimetres by 80 millimetres. Each sheet costs $24. How many sheets will be required and what is the cost? So what we've got to figure out is the area of one of these papers and then how many of those areas are required to cover this surface. Alright, so each square has an area of 8 by 8, which is 64 centimetres squared. We want to know how many 64s go into 433. So we need 6.8 sheets. We're going to round up because if we buy 6, that won't be enough. So we'll round up to 7 and then multiply by $24, that's $168. Okay, last question. An Olympic pool needs to be retiled. Calculate the surface area and the cost of the tiles if tiles sell for $25 per metre squared. Alright, so let's make a plan. So we're going to have two trapeziums. They're these shapes here, the front and the back. We have got bottom rectangle, we have got a left-hand side rectangle, and we've got a right-hand side rectangle. Now there's a couple that we can work out straight away, which are the left and right rectangles, so let's do that. So the left rectangle is going to be 2.2 by 25, which is 55 metres squared, and the right rectangle will be 1.1 by 25, which is 27.5 metres squared. Let's have a look at the trapezium now. We can tell this is a trapezium because it's got a pair of parallel lines here, and the perpendicular height is 50. So what we're going to do is put it into the formula, which is h on 2 and then brackets a plus b. A and b are the parallel sides. So 50 divided by 2, and then outside of brackets 2.2 plus 1.1, that gives us 82.5 metres squared. So far we've got our left rectangle and our right rectangle, and now we have our two trapeziums, which is 165 metres squared. So all that remains is to work out the bottom rectangle, but we don't know this length here. So we're going to have to use Pythagoras' theorem to work that out. Okay, so there's the trapezium, and what I've done is just split this up into a rectangle and a triangle. So that's 50 metres there, and this is 1.1. I've just done 2.2 take away 1.1. Okay, we're going to do Pythagoras' theorem here. X squared is equal to 50 squared plus 1.1 squared, which is equal to 2501.21. Doing the square root, we get 50.01. It looks a little bit strange, that number, but look at the difference in the magnitudes. This is just a little bit over a metre, and that's 50 metres. So this hypotenuse is going to be pretty close to 50 metres, which it is. Okay, now we can work out the area of the bottom rectangle. Okay, so that's what we've got so far, and the bottom rectangle is now going to be 50.01 multiplied by 25, which gives us 1250.3. Okay, so to find our surface area, we add up all of those numbers, which gives us 1497.8 meters squared. And then finally, the cost of the tiles. Every meter squared costs $25, so we multiply these two numbers. And that gives us $37,445. Okay, that brings us to the end of the topic. If you want to continue on with measurement, the next topic would be volume.